Hey, you guys. As you can probably tell, I'm a little stuffy when it comes to teaching, so please bear with me. But you should be watching this tonight. Today is Wednesday. It is September 8th, and you will be given a paper that looks just like this tomorrow. The very first part of this is going to be part of your notes. So, this is the part that you will need to memorize when it comes to this. So just bear with me. I'm doing this on my laptop, and my laptop's touchscreen, so just bear with me if y'all don't mind. So let's go ahead and get started with rational and irrational numbers. This, you guys, is stuff that you learned last year, but again, just like I said in the Google Classroom message, this is straight up memorization, okay? So irrational numbers are numbers that cannot, all right, so let me see if I can write that. Maybe not. Oh, Lord. Okay. Okay. I think I got it to work, so let's try this again. So irrational numbers are numbers that cannot be expressed as a ratio between two numbers, meaning it cannot be written as a fraction, okay? Cannot be written as a fraction. Ooh, this is gonna be janky. Okay, so some examples of irrational numbers are going to be numbers that are imperfect squares, meaning the square root of 2. Wow. Or pi is a really good irrational number. All right, the square root of 3 is not a perfect square, so that's a good irrational number. On the other hand, rational numbers can be expressed as a ratio, meaning they can be written as a fraction. All right, meaning 2/3 is a fraction, so that means that it is rational. The square root of 25 is a perfect square, and that is 5, and 5 can be written as a fraction. Some other things that can be rational numbers are repeating decimals, meaning numbers that decimals that repeat, 2.1, but it has a little hat over it repeating. Now, it's not a ninth grade standard for us to teach you what or how that can be converted into a fraction, but all you need to know is that it can be written as a fraction. Some other things, any sort of decimals, maybe like 3.5, that can be written as a fraction, even though it's not repeating. Some things that have a pattern, maybe 2.0675, maybe that is repeating, so that has a pattern, meaning it is also a rational number. So the other part of your notes that's also really important here is when we're adding or when we're multiplying rational and irrational numbers, okay? So if you're adding rational plus rational, your answer is going to be rational. Anything that has irrational in it, when you're adding rational, irrational, or even irrational and irrational, your answer is always going to be irrational for both of these. So anything when it comes to adding irrational numbers, your answer is going to be irrational. Now, multiplying, on the other hand, when you're multiplying two rational numbers, your product is going to be rational. Now, same thing when it comes to multiplying rational and irrational, your answer is going to be irrational. And then also irrational times irrational is irrational. Now, the only thing that you need to check is if you're multiplying square roots. Because remember, when we multiply square roots, so say for instance, we had the square roots of, let's say, 2 times the square root of 8. Now, the way that we solved for this was that we multiplied our two radicands, and that gave us the square root of 16. Now, both of these are still irrational. Square root of 2 is irrational. It's not a perfect square. But if I multiply here, the square root of 8, also still irrational, I get the square root of 16. Well, the square root of 16 is a perfect square, meaning that's going to be 4. And that is, you guys, rational. So you have to be careful when you're talking about perfect squares here, okay? Sometimes when you multiply your radicals, you could end up with a perfect square. So that's one of the things that you really have to be careful about. Now, that's as far as the notes go, meaning this table right here is straight up memorization, okay? You just have to know rational plus rational is still rational, all right? Rational and irrational is irrational, all right? And just make sure when you're multiplying that you check for your perfect squares, okay? So I'm going to make a separate video when it talks about going over these answers, especially with the practice. Now, the notes, this first part, that is something that you have to know. You have to memorize because you're going to have a quiz over this on Friday, a very, very short quiz, okay? So make sure that you memorize this. I'm going to post some more videos for you guys. Hopefully I get to be able to see you guys soon, all right? Love y'all, miss y'all. Hope y'all are being good for my sub. Okay, see you later.